All right, welcome back to episode 11. In this episode, we're going to implement the cache that we've been working on storing data for. This might be difficult to see, but I'm going to go through the storage system. So every browser has IndexedDB. Maybe I can make this bigger. Yeah, there we go. And we are writing to IndexedDB right now, player data and server data. So if we were to look at servers, you can see that we've got 4 Sigma, period, AeroCorp, so on and so forth. Let's just look at food and stuff right now. So basically, this is a server object that has in it all of the most recent data. Now, it's not up to the second data. Like when we're working off of what I call the live server object, that is up to the second data. It goes and queries the data exactly when we desire it, which is really good for decision making, especially with like batching, because you're really working off of millisecond decisions. Has something ended? Has it started? The cache is updated every 60 seconds, which is not nearly fast enough to make decisions off of, but it is fast enough to get basic information from, like as a user, like monitoring and stuff. And what's nice about the cache is that it is free. It costs no RAM to use. So take a look at food and stuff. We can look at like the amount of RAM that's on it. If you scroll down, you can look at PIDs, targeting PIDs. Here, let me be better if I showed you Noodles, because Noodles actually has targeting PIDs, because it should have targeting PIDs. It doesn't right now, but it will. Basically, this is a list of all the processes targeting Noodles. This is a list of all the processes Noodles is running. We can see how much money is on it, max money, available money. We can see if it's a target, if it's tracker, if it's ready for HWGW batches. Basically just a lot of really good information. But we haven't yet written the scripts to use this. So today I'm going to write a basic list script. Basically give us information about all of our available servers, tell us data about them. And to do this, I'm going to implement Pretty Table. Pretty Table is open source. I didn't write this. Somebody way better than me did. But it's available in the GitHub. You can just go and grab it. And what it allows us to do, I made one modification to it, which is here, I think. I'm not sure. I think I had to change this line. But anyway, just go and grab it, install it, because we're going to be importing it. And we're going to start a script called user.list.js. Importing Pretty Table and importing HandleDB, which we'll use later. So the first thing we're going to do is I'm actually going to import base server. And as soon as I import base server, I have to pay get server costs. And that's what we're going to avoid by the end of the video. But to start with, we're going to use base server. So we're going to also grab dplist. Such a crucial script. It's in lib.utils. We're going to start this the same way we start every script. Let servers. generating an array of server objects. The next thing to do is to sort the server objects. So I'm going to do servers.sort. I'm going to sort them ascending based on level. Then I'm going to instantiate pretty table. And pretty table works by defining headers and rows just like Excel or a CSV. And I'm going to set my headers to server name, level, hat, cache, sec increase, and RAM. I'm going to let rows become servers.map. And I'm going to map essentially a row that is these values here. So the first one will be s.id, that's your server name. Then s.level. Then for hacked, I'm going to check if we're admin. Then I'm going to check if we've backdoored the server. And if we're, the way these question marks work, by the way, is the basic syntax is if sadmin, and if not sadmin, that's it. So it's Boolean question mark, true, and then false. That's the syntax we're using here. And I'll explain this in just a second. Okay. So this nested if one-liner works from the inside out. So are we backdoored? If so, we're going to return this Unicode value, which is just a fancy K. So it's going to say kit. And if we're not backdoored, but we are admin, we're going to return root. This is just a fancy Unicode value for an R. And if neither of these are true, we're going to return S ports required, which is the number of ports required to gain root. So that's just the way I do it to keep it all in one line. You could just write a big long if statement and do it that way. That would be perfectly fine. Next up is cache. So we're going to use the informat utility. Now what this says is return a percentage of cache, money available over money max, or if this can't be resolved, for instance, if money max is 0, and this would be dividing by 0, or return a blank. So this way you won't ever get like a null or a void or an infinite value, you'll just get a blank. And then informat takes as its second argument a format string, and this is the format string to print this value as a percentage. That's just what it is. You could also do like 0.00, which would be a percentage with 2 decimal places, 1 decimal place. I don't want any decimal places. I just want like, if it's 75%, tell me 75%, not 75.624. Next, we're going to do informat. And this is for sec increase. I think I can just use a 0 there. Actually, I think for this one I will want a decimal place because 3.5 is different than 3. So this is going to take the max of 0 and security level minus security min and return the value as a string that's formatted the way we want. And last but not least, the RAM. Now we could do this in RAM or we could do this in Power. I think I'm going to do it in Power. Because RAM's complicated. RAM, you gotta like multiply by 1024 a bunch of times to convert it into gigabytes, terabytes, whatever you're trying to convert it into. But power's simple, and it makes sense to me. All right, now we just have to pt.create headers rows. Wait, did I ever instantiate pretty table? Yeah, let pt equals new pretty table. Cool. pt create headers rows, and then ns.tprint pt.print. That's it. So if we run what we just created, there it is. A list of all of our servers. Name, level, sorted, ascending, like we wanted. Hack status, so do we have root? Have we not backdoored anybody on this run? We have not backdoored anybody. Oh. Sometimes I forget I have to type that manually. All right, now you see that we've got a rootkit on CSEC. So that's been backdoored. Second crease. I don't know that I want to return 0, 0 if it can't be hacked. I think I'm going to modify that. Actually, no, that's not right yet. I think instead I want to do s.isTarget. And if they're not a target, return just blanks. That way I'll still get my zeros on servers that are zeros, that have a security level and can be hacked. Well, okay, it's base server doesn't have his target. That's okay, because the cache will. All right, so now you see these are my targets and their security levels. These are not targets, so they have no value in security or cache. And these are not targets because they haven't been rooted yet, or we haven't achieved the requisite level to attack them. So they're not even targets. So that's how we can see kind of in a quick one-liner what's going on with all of our servers. And it really is just like one line because all of this is technically one line. Okay. Is there anything else we'd change? Maybe instead of having this give us our required ports, maybe we could have it give us remaining ports. So since our script automatically, never mind, I thought our script automatically opened ports. Well, the syntax is right, so I guess we don't automatically open ports. So I'll just have to do, I was gonna say I'd do player ports, but I don't really want to implement player in this function. We'll just leave it as sports required, and that'll be clear enough because we will know how many ports we have simply by the fact that There are no 4s here, but there are 5s. So we've got 4 pieces of software. Cache looks good. Noodle's at 100%. Yeah, that power really comes in handy on our clusters. We can see we've got a 10, 11, a couple 12s, and a bunch of 8s. Let's go with this. Next step. Right now this uses 4.8 gigs of RAM. Let's make it use 1.6. And to do that, we're going to take out base server hackable. And we're going to import actually I can just import this from if.cache. And everything else will be the same. The only thing that'll change is base server hackable. When we import and use that, it is a expensive function, costs like 3 gigs. And when we don't, it'll cost nothing. We've still got an import error because we haven't actually created if.cache yet. But we'll do that now. So in if.cache, we're going to want to import handledb. Bring in handledb, and then nothing else. We won't even need a main on this. We'll export a class called server cache. Give it the same constructor. Define its ID. Now, of note, server hackable, that class which extends base server, it has some special functions on it. It has functions like sudo. This cache will not have those functions. This cache will only have the functions that we define here in this cache. So it's going to be critical to only define functions that are free, or essentially free, but ideally free. The thread count is free. So we'll redefine it here. Actually, I'm not using strict mode anymore. Okay, so we got that. Next, we need uncache. This is our one function that we need on server cache. Stuff like thread count, those are all optional, but we need uncache. And what uncache is going to do, and I honestly do not expect many people to understand this, but I will explain it. I'm going to return an IIFE, an instantaneous execution function. I don't know what the hell that means. Basically, it's an IIFE. And that's going to be an async function. And we have to structure it like this because reasons. Try class db equals await handle db. Data equals await db get servers this.id, and we have access to this ID because we're passing it in. For let prop of object.keys data. So we're going to go through all the keys of data, which is returned by this. And for every key, which we're defining with the instant variable prop, we're going to set this prop to what data prop was, which is nice because our cache function, which is in server base or base server, it does the opposite. It takes everything that is this prop and sets it to data prop and then pushes it out into the cache. So this just reverses that. Then we're going to return this and catch return null. And then to make this an IIFE, we add call parentheses like this, and that should be good to go. Note the RAM cost. Essentially free. So now our server cache does work, and our RAM has been updated, and the only costs that we have are for scan, which is required for dplist. We could reduce this further. I'm not going to, but we could. If we really wanted to cut that last 0.2 out, we would define a function that was like get all servers from cache, which why not? Let's just do it. Function get all from cache, and we'll pass in type. And what this is going to do is std wait handle db. Get all and then type. So now if we were to call this I don't understand where my syntax error is. Maybe I can't use type. Oh, not an async function. That's it. That's all there is to it. So we're creating an async function get all from cache, and then we'll go back to user list. Well, first, let me show you that this works before we make that other change. Import not found default. Because that is not a default export. We've got to surround it in the braces. S.ports is undefined. Really? I think that might be a separate problem. Yeah, so I haven't actually implemented the update cache loop yet. Oh, it's two problems. First problem solved. We're going to start the update cache loop and we're going to catch any errors. Second problem is over in user list. When you're working with server cache interface, you have to do it slightly different. You have to first stick it on a variable so that you can await server.uncache. And once server.uncache runs, you can push it to your list. So just a slight change in how you define and instantiate it. Let's kill and relaunch Go. so that that update loop will start. Stop ports is undefined. All right, let's figure that out real quick. I mean, there's ports right there, so it's clearly defined. It's just not defined on everything. And I'm thinking it has something to do with our new purchased servers. Got 97 errors. Sleep tried to run get server. Okay. Yeah. Another problem with doing it this essentially infinite loop inside the player function. You can't use sleep anymore. You have to use asleep. Minor change, and it only applies to your main script, the one that updates the cache. That one cannot use any more sleeps, but asleep works exactly the same. It just doesn't throw errors. Let's kill this, run it, and run user list, and there we go. That is now the cached version. And you know it's the cache version because if we come over to food and stuff, and note that food and stuff is currently a 7 sec. We have weakened it, but it still shows a 7 sec, even though that weaken operation completed just fine. And it should show 7 point or 6.9 or something. Or maybe it's rounding up. Either way, it won't update immediately. That's my point. Yeah, it could actually be that it's rounding up, and that's why we're not seeing an update. Let's do one more. Oh, now it's showing 6.9, so that is updating pretty quickly. What? Curious what loop timing I set. That's 60 seconds. Yeah, 60 seconds in both places, so who cares? What matters is this guy no longer uses 4 gigs of RAM. He uses 1.8. And since we said we were going to make it 1.6, we'll take out the DP list, and from IF cache we'll import get all from cache servers. Oh, can I not do that? Oh, of course I can't. I'm retarded. Let slist equal all from cache. Hopefully this will work exactly the same way. Oh, I forgot to export it. Export async function. Oh, and I'll also have to await that, because that is async. Well, it almost worked. I think the command is get all. Actually not 100% sure of that. Oh. I'm missing. Oh, okay. This is not a servers list. These are different. DP list and get all from cache returns different types of objects. The old one, DP list, returns just the list of host names, and this actually returns objects. So we have to slightly restructure this guy. There we go. Now we're pulling all that data straight from the cache. And notice how the order changed, because the cache, I mean, it's still in incremental ascending order, but because the cache stores things in alphabetical order as well, we get this sort plus the alphabetical sort. So definitely working from the cache. And that's it. That's how you use the cache for grabbing existing data that does not have to be updated at this very second free, right? It's 1.6 gigs. So I'm going to use this as a standard in this function. The only thing I'm going to change is I'm going to print and run it on a loop. I'm going to clear the log. I'm pretty sure you can sleep here, but if there's any problems, change that to a sleep. So 1 second is way too fast. It can't even pull from the cache that quickly. Yeah, look at the flashing on and off. That's how long it takes to pull all the servers from the cache. But we can fix that by just moving clear log down here. So it'll hold the old data until it's got the new data. Beautiful. A little bit bigger than I would hope. But I'm not sure what I can cut off of it. I kind of need all this data. So we'll just keep it rolled up like that, and when we need it, pop it down. And I'm going to make one more modification to this. I'm going to say let nsargs, let tailed equals nsargs 0. And then I'm going to do so if I pass true in, it's going to be a tailed version of this. So it'll be in this little print console log. And I should probably also ns.tail. But if it's not tailed, I'm going to send it to tprint. So if I just run user.list, Almost there. The problem is these are all defined inside this block. Let's do it like this instead. All right, so if we have set the tailed, if we call this with run user list tailed, it won't print out the terminal version, it'll create this version. And if we don't run it with that variable, it'll just print it out to the terminal. So we won't have to deal with, do we want this to run forever? Do we want it to run once? It'll just be clear. Okay. I'm just going to alias that. I can do list tail. Or just list. Beautiful. Actually, I think if a server has no power, I'm not going to show a 0. Perfect. All right, I wish there was a more compact way to format this, but there's not, so this is what we deal with. The cache is really useful for a lot of stuff, and just to wrap this video up, I'll show you an example of how we would add the player cache. I'll just go in and add it because we'll use it in the future. Literally just copy and paste this. Call it player cache. Change, not really a host name when you're talking about a player. Won't need thread count. And this is players. And now the player cache is done. It's just going to work. And if we were to have another type of cache, just copy and paste it, do the same thing. All that really matters is that your constructor is the same because of this call right here. The dp get players this.id. The ID is the primary key for the table. So you have to pass it into the player cache so it knows what primary key to get. All right. I'm gonna try something else that I've never done before, but it's been like in the back of my head that I wanted to do it. And so if you want, I would say quit this video now. The stuff I'm about to do, it's going to be uploaded in the GitHub if it works, and I may burn 20 minutes on something that doesn't work here. And I'm still going to upload it because I think it's important for you to see failure as well as success, and I'm not sure it's going to fail. I just don't know how the hell to do it. So I'm going to modify this, my server object. What I want to do, actually I'm going to do the player object. A little bit easier. What I want to do is write to the cache, instead of doing it like we're doing it now, which is write to the cache every 60 seconds. I would like to be able to define event listeners so that, for instance, if this changes, if market API 4 sigma changes, I would like to write it to the cache immediately rather than waiting for 60 seconds. Likewise, if like faction membership changes, I would like to write that immediately to the cache rather than waiting 60 seconds for it to update. And to do that, I think what I have to do is, I'm just going to hack at something for a minute. Start with that. Say let old value equals this dot field. I'll wrap this in a loop. This is going to have to be an async loop. And I may asleep for 1. I'll probably take this out as well. I don't know that I have to sleep this. Mike can just let it run, but for now, just so we can get past the initial bug testing of why does nothing work, we're going to put the sleep in. In fact, I'll probably put it in at 10. So let old value is this field. If old value is not equal to this dot, yeah. Yeah, so what this does is, no, it's not going to be this dot. It's just going to be the variable name. What this does is it creates a listener for a specific field, like, what's a good, money, like money. And it sets the old value to the current value of player.money. And while true, if old value is different, so if the one we set initially is different than the current value, we're going to update the old value and try to update the cache. And then we're going to sleep. The problem with this as is, there's no way to get nested fields. So I can get player.money, but I can't get player.hacking.level, for example, because that's a nested field. But we're just going to test this and make sure I can get player.money, and I'm going to print out that we did try to update the cache. I'm going to create a event listener script. It's just going to be like a test script. And I'm going to have to import player. And then I'm going to try to add an event listener for the field. Let's just do money. And I'm not going to await that even though it's an async, because it's going to just loop forever, infinite loop. close some of my tabs. All right, let's run this. I don't know if it's going to work or not. Yeah, I can already see that we're having a problem because this should be firing all the time. Money's constantly being updated. Let's see if we can go into our console. NS is not defined. Okay, well that would do it. Okay, that locked me up. Let's raise. I don't know why that locked me up. It should not have locked me up. Well, something's the matter because it just did it again. Oh, that's what it is. I was continuously creating event listeners. I just need to create it once. Dang. I got locked up again. I gotta say, the weird thing is I have sleeps everywhere. While true sleep. Over here I have while true sleep. So maybe 1000 is just too fast. Maybe it's this await here. Oh, that's what it is. Okay, I'm not locked up now. And it's updating the cache. Let's make sure the cache is actually getting updated. So basically, can I see money from here? I cannot. Ends in 865, I hit refresh. Ends in 731, I hit refresh. 542. Okay, so that is updating every time my money changes. And we know that it is because the normal loop is every 60 seconds. And what makes this kind of cool is obviously money's not going to be the right thing to use here. We'd want to use something that updated a little bit less quickly. But I will be able to take out this forever repeating loop so long as every type of object, players and servers, have some kind of event listener that updates, that can be expected to update on a reasonable schedule. I probably will leave in this if repeat 60-second loop because that ensures it updates. I may up that to like 2 minutes. But yeah, if I define, like when this cache updates, it updates everything. It doesn't just update money, it updates all the values. And so if I've got something that changes, every 3 minutes, this will update every 3 minutes. So I want to set this to basically the highest priority, most frequent knowledge that I will need on a regular basis. And I could also set multiple event listeners, like say I don't care about money updating every second. I could do ports. I could do hacking level. And then those will fire independently. Like ports will fire and hacking level will fire. So if a port gets updated and then 1 second later hacking level gets updated, it'll fire twice, which is fine because we can define all the information that we want instant updates on and get functionally instant updates. In fact, what I was going to try doing was dropping this down to 1. Actually, no, this doesn't matter. This value has no bearing on anything. It's this one. Now, right now it's firing every 100 milliseconds. Ideally, once I update this, it will fire, well, since it's tracking money and money's changing constantly, it'll fire whenever a hack finishes. But it shouldn't fire every 1 millisecond, which that seems pretty good. Oh, except I don't have any hacks. So it shouldn't be updating at all. Oh no, I do. I have Hacknet. Hacknet's giving me money. And Hacknet is a 200 millisecond loop. But I'm happy that it's not updating every millisecond. That tells me that it's working. Okay, so the only thing that I'm missing is this works for player money, but it doesn't work for level. That kind of structure. And I've written code for this before. But hell if I know where I put it. That was ages ago. literally like 3 versions of Phoenix OS before is when I wrote this script last. I don't have that code anymore. I would have to dig and dig and dig. So we'll recreate it. And I'm actually going to do it in Event Listener. Let me comment all this out and say let field equals nsargs 0. We'll print something called result. And that'll look something like hacking.money. And so result will be field.split. And we're going to split it on the periods. And that'll give us an array like hacking money. And what we're trying to get to is this. And I think I'm going to have to do like a recursive function. So let's define a function, const embed object is equal to object, and we're going to return obj. Okay. Maybe I'll do like result equals result dot map. So for every item in the array, I want to call embedded object no, this is not going to, I'm going to have to do a for loop. So let field of result player equals embedded object player field. That's looking better. I'm going to change some of these definitions. Field set, flip fields. I really don't want to overwrite my player variable like this. I'll define subobj as player. And I should just be able to subobj. Let's see if this works. Let's see if this returns. I run event listener with hacking.money. Okay, why didn't this work? Okay. hacking.level. Perfect, 324. And if I run it with money, beautiful. I cannot believe that was that simple. So now we just have to duplicate that over here. So I'm passing in a field set that looks like that, which is the same as nsargs0. Let's call that field set. Subob equals this for let field of split fields. And then I just printed the value of subobj. Yeah. Oh no, hold on. That's good. That'll work. Come back over to event listener. Don't need any of that anymore. Not working. Is we're creating an event listener with the field set. We're splitting it. That's all correct. We're defining a function, embedded object, object field. Subobject is this, which is player. Let field of split fields. We're reassigning subobject to embedded object. Subobject field. So basically this just sticks that on that. And on the first iteration, it'll become hacking object, and the second iteration will become level object. And we're saying let old value equal subobjects. Okay, yeah, and then okay, so I'm gonna have to move this down. I'll have to live inside the while loop. This won't. It honestly might have been as simple as that, but I think that may work. Yeah, there we go. On the first iteration, there was a change in hacking level. Let's run go.js and see if we get updated cache due to a change in hacking level here in just a second. We'll use our switch command to switch to HWGW. So we're at 324 now, and this ought to flip 325, and we'll get one line that says updated due to change in hacking level. There it is. Beautiful. I'm kind of surprised that worked. Yeah, we won't need event listener anymore because we're going to put this straight in our go loop. I'll keep the update cache in just for now because I don't fully trust this yet. What do we want to watch for? We'll watch for a change in admin. We'll watch for a change in backdoored. On player, we'll watch for a change in faction membership. That should do us. This is going to be a problem. My loop actually starts down here, but during this loop, I could add new servers. Like when you purchase a server, that is a new server. How are we going to square that away? I'll tell you what, I'm not, because not in this video, because right now the only things I'm watching for are admin and backdoored, and those will never apply to a purchase server. Let's just run go. See if it crashes. Oh, yep, okay. No big deal. Actually, probably the thing to do would be, instead of just copying and pasting this, remember we're trying to be good programmers and not repeat ourselves. I'll create a class cacheable. No constructor. We'll have one function, create event listener field set. and I'll make base player extend cacheable. Oh, you know, I gotta export. And also I may need a super. Yeah, I got a super. The super says, hey, go to the parent and get all of its methods too. Let's see if it's working. I'm tracking hacking level and faction membership. But I'll look at the updated at value, so 923, and I'll wait until this hits 329 and see if that's changed. I see that at. Well, actually, I'll do it from here. That way I can update constantly. I want to see just how quick it changes. Clickety click click. Money is actually updating much faster than I thought it would. Money is going up every single time I click. I feel like that shouldn't be happening. Yeah, I don't know if all those errors are related. Now we got 329, but that doesn't tell us anything because the thing's updating constantly. I think it's likely let's take out the update cache just so there's nothing else calling the cache except for our new stuff. we're at 351 on updated at. Yeah, it's updating constantly. The reason why I don't want it to update constantly is because that's just going to pepper the database. Okay, so we're calling this update cache with false. What the heck? All right, well, how about this? I think as far as an educational tutorial, this has gone about as far as it can go. I'm going to go and debug this, figure out why, like what I'm missing. Something somewhere is just causing update cache to run constantly, and it could be literally anything. It might not even be this script. It could be my, in fact, I'm pretty sure it's, I bet it's this. I bet I put update cache in this script. I didn't. I don't know. But something is causing everything to go haywire. But I'm going to upload, I'm going to fix this, and then once it's fixed, I'm going to upload all of the cache changes under the episode 11 GitHub, and it should be working by then. Thanks for watching. See you next time.